Now, here in this lecture, we are going to study about the next method of the analysis of truss, that is method of section. If a body is in equilibrium, then any part of body is also in equilibrium. This is the consideration. This method is very easy as compared to the method of joint. And this method can be utilized to calculate the forces in designed member. This is very important point about the method of section. In method of joint, we have to calculate the forces in all member. And if we have to calculate the forces in design member, then we can use the method of section. Now the steps of the method of section. First step, if some length angles are missing, then find them by using the geometry. Then second step, which is as similar as in method of joint, that is draw the FBD of truss, apply the conditions of equilibrium and find out the support reactions. Then in this method, the third step is different, that is draw the section line passing through the members, that is maximum 3 members, where it is dividing the truss into the two complete separate parts. Then step number 5, select any one part and apply the conditions of equilibrium and find out the forces in member. Here you can apply the third condition of equilibrium also, that is summation of moment is equal to 0. Then last is the tabulate the magnitude and nature of the members. So this is the one numerical which is based on the method of section. Numerical is determine the force in member. Here the member is mentioned, means we have to use we must use here the method of section. FE, FC and BC of the truss using method of section. Given data is P1 is equal to 2.22 kilonewton and P2 is equal to 6.66 kilonewton. And this is the given figure. Truss having the span 9 meter and height 3 meter. External forces acted at point B and C of magnitude 2.22 kilonewton and 6.66 kilonewton respectively. At joint A, there is a hinge support and at joint D, there is a roller. Now, according to step number 1, draw the FBD of entire truss with support reaction. Next, apply the conditions of equilibrium to the FBD of entire truss, which is summation of moment about point A is equal to 0. We get equation RD into 9 minus 2.22 into 3 minus 6.66 into 6 is equal to 0, and we get the value of RD is equal to 5.15 kilonewton in upward direction. Then apply another condition, summation Fy is equal to 0, which gives AY plus RD minus 2.22 minus 6.66 is equal to 0, and from this equation we get the value of AY is equal to 3.7 kilonewton in upward direction. Then apply the third condition, summation Fx equal to 0, which gives the value of Ax equal to 0. Now draw the section line which is passing through the member FE, FC and BC. So see, in this figure we draw the section line NN which is passing through the all three members. Now take the FBD of right hand portion of the section line. So this is the FBD of right hand side portion of the section line. Then apply conditions of equilibrium and on the right hand side portion of the section line. So here first we apply the condition, that is moment about point C is equal to 0. So taking moment about point C is equal to 0, we get the value of FEF, means force in member EF, which is equal to minus 5.18 kilonewton, means the force is having compression nature with magnitude 5.18 kilonewton. Then apply another condition. Summation of moment about point F is equal to 0. Applying this equation, you will get the value of FCB is equal to 3.7 kilonewton having nature tension. Then apply the another condition. Summation of Fy is equal to 0. You will get the equation FCF sin 45 minus 6.66 plus 5.18 is equal to 0, and from this you will get the value of FCF is equal to 2.09 kilonewton tension in nature. And last step is the tabulate the result with serial number, members, magnitude and their nature. So in member EF, force having magnitude 5.18 kilonewton and nature compression. In member CF, force having magnitude 2.09 kilonewton and nature tension. And in member BC, force having magnitude 3.7 kilonewton and nature is the tension. So this is the numerical which is based on the method of section.